Hello everyone, this is the second question from the second round paper last year. It is a functional equation and there is a little trap that is going to be pretty prominent in the middle. So I'll talk about that when we get there. For those of you who have not really handled functional equations that much, there are just a few tips that I can highlight along the way. Now the first tip is that for convenience sake, a lot of times we would write something like let pxy be the assertion that, and then just write the whole thing down. Right, so f of 1 minus xy fx plus x squared fy equals to fx. Now the reason why you want to do this is that you will have a bit of a headache when later you try to say, okay, I'm going to now let x equals to y and y equal to x, which means swap them around, and then writing down substitute x equals to y equals to x starts to look really weird. But if you just write pyx, then we know what you're referring to, right? It just means that in all the places that x appears, put in y, all the places that y appears, put in x. And that's permitted because this is true for all real numbers x and y. Now, this is for presentation's sake and also for our sanity's sake. The next tip is a little bit cropped off at the side, so let me adjust that, the word let. Okay, there we go. The next thing that we want to highlight is that for functional equations, you can substitute in anything. Now by substituting anything, I mean you can put in 0, 1, -1, you could put in x equals to y equals to x, y is 1 over x, anything you like. And usually we like to start with the simplest values possible. So let's begin with something like 1 and 1. So remember from what we've written here, this means I'm letting x equal to 1 and y equal to 1. Now, the first thing becomes f of 0. The second one becomes f of 1, and the third thing becomes also f of 1. So this tells me that for my function, f of 0 is equal to 0. Okay, so we have found something. Now since I know that f of 0 is 0, it makes sense to substitute in 0 somewhere. If you try putting x equals to 0, the whole equation just becomes 0 equals to 0. It's going to vanish, so that's useless. But we can try putting in y equals to 0. So y equals to 0 would give me f of x. F of 0 is 0, so f of x equals to f of x. Now remember that when you see something like f of x equals to fx, this is usually going to come in quite handy at some point. If you have multiple functions, f of f or something like that, you can just squash it down. So we don't mind that. Now, if you continue putting in numbers, it may give you some results, but it isn't going to really give you any great news. So the next thing I'm going to do is to make use of the fact that I now know f of x is just f of x, and I'm going to substitute in y equals to f of x. So y equals to f of x means that the f of x is going to become fx when I get there. So let's write down what we get. 1 minus x fx. It's quite a mouthful, right? Plus x squared fx, which is just fx itself, is equal to f of x. So I'm going to now shift it over, forgetting the bracket there. Now I'm presenting the solution here in terms of some reasonable substitutions. However, there are a lot of other reasonable substitutions that also work, or may even be faster than what I'm doing here. So please don't assume that what I'm saying is gospel. You don't really need to follow it in this sequence. You may make some other useless substitutions, you may make some substitutions that are even better than what I thought of, and that's okay. Now, what I see here is that I do have another way of getting roughly the same thing. Right? I want to basically try to make this thing appear out of my original equation in a different way. And so what I'm going to try to do is simply to make the f of 1 minus xy fx also look like this. So how do I do that? Well, if you play around a little, you realize that you can do a substitution and you replace x by f of x and you replace y by x. Now let's see what happens when we do this. We're going to get f of 1 minus x of x and f of x, which is still going to be f of x. But what's left over is now going to be different, right? Because I used two different things. From x and fx, now I flipped it around and used fx and x. So surely this is going to make things look different for the remaining terms. The x has been replaced by fx. So fx squared times f of x again is equal to f of x, which is fx itself. Now, I know this is very confusing, so feel free to pause the video anytime and try to work out the details on your own. So it means that I have the correct number of brackets. Let me just make sure I have this right. So now you get a different expression for the same thing, right? Compared to earlier on, we got this and we got this. So it looks like we're almost done, and in some way we are almost done. Right? We have gotten to something pretty nice here. Fx 1 minus x squared equals to fx 1 minus fx whole thing squared. Now it looks like this implies fx is 0 if we have the outer terms are equal, and if they're not equal we can cancel it off and say that x squared equals to fx squared, so fx is equal to x or minus x. If you are looking at the length of the video, you know that this is not the end of the solution, right? I also mentioned a trap earlier, but you know that this is not the end of the solution because, yeah, we are only 8 minutes in right now. So what's the trap? The trap is that this is not a definition of the function as a whole. It is for each x that we have established this. Now I use for each x instead of for all x. Technically they mean roughly the same thing, but linguistically I want to emphasize for each x. That means that it still could be possible that fx is sometimes equals to 0, sometimes equals to x, and sometimes equal to negative x. Like for example, how do we know that fx equals to the absolute value of x isn't going to work, right? That means there is x on one half and negative x on the other half. Some of you may know what's the ReLU function for machine learning, which is that for negative x is 0, for positive x you take x. How do we know that that doesn't work? And how do we know that there isn't some more exotic combination of these? So this is known as the pointwise trap, because so many people make it, that's why it is actually got a special name. It's not that the question setters are trying to trap you, it's more that we have this implicit understanding that any function must have a formula associated with it. And that is not necessarily true, right? So for example, the famous Dirichlet function is that for any rational number, f of x is going to be 1, and for an irrational number, f of x is equal to 0. That is also a function. A function could be very strange. It may not have a nice formula. It is just a mapping between some things in the domain, everything in the domain, to certain values in the range. Now with that understanding, let us try to now deal with this pointwise trap. It's not a very difficult thing, but we have to be very careful in what we do. Now, first of all, if we can get a 0 somewhere, it more or less will kill everything off. I remember that I'm still going to use the pxy as the assertion, blah blah blah. So, firstly, if f of a equals to 0 for some non-zero a, then I'm just going to put in x equals to a. Now by putting x equals to a, all the f(x's) will disappear, and you are just left with a squared f of y equals to 0. Clearly, this simply means that f of y is 0 everywhere else. So that is one case, which means that if it's 0 anywhere, then it's 0 everywhere. Now, otherwise, it means that the other two cases must hold, right? Our other two cases are that it is either going to be x or negative x. So otherwise, fx equals to x or negative x for all x. Now technically for 0, f0 is 0, so it also is going to be included in here, no problems there. So let's try to think about how can I disambiguate this. How can I make sure that fx equals to x and fx equals to negative x don't happen like alternatingly or at some places here, some places there. Now I'm going to rewrite the original thing that you see at the top of the screen, the original statement, just slightly. I'll rearrange it a bit for convenience sake. Oops, I'm writing the wrong thing, x, y. Yeah, getting ahead of myself. I'm trying to do the substitution already before I said I'm going to do the substitution, so let me just copy it down first. Okay. Now, because of what we have seen from earlier, which is that fx equals to f of x and f of y equals to f of y, I'm going to now replace f of y by, replace y by f of y, which does not change f of y. So if I replace it like this, and I'll just replace it into this form. This is just equivalent to what we have at the top. Now what we want to do is to always try to make one side remain the same and change the other side, because it means that we have found two things which are equal to each other because they are both equal to the same thing. So the right side in this case is the same. So the right side is the same. It means that these two here must be the same. Now if they are the same, because now I know that fx is x or negative x for all x, it means that you get plus minus 1. Right? They are plus minus of each other rather. So it means that 1 minus xy fx is going to be equal to plus or minus 1 minus x fy fx. Now, if we suppose that x is non-zero, then we can cancel off fx because we have established that it cannot be 0, otherwise everything is 0. Okay, so we cancel off fx, and now we're left with 1 minus xy equals to plus or minus 1 minus x fy. And this is for all x they are not 0, and for all y. Now, notice also that f of y is itself plus or minus y. So it's plus or minus 1 plus or minus xy. Now, we more or less want to say that this must imply that, well, the signs must match up. The only way that the signs can match up is that this must be a plus, and behind it must give you f of y is also equal to y. Right, so I will just write this a little bit more neatly as a proof by a very miniature proof by contradiction. So suppose f of y equals to negative y for some y. That means that 1 minus xy is equal to plus or minus 1 minus x times negative y. So 1 plus xy for all x. You can see something is wrong here, right? So what is wrong? What is wrong is just very simply, if it's the positive case, and x is non-zero, y is non-zero, you get a contradiction. If it is the negative case, then you are going to just find that 2 equals to 0, so that's also a contradiction. Okay, so both cases reach a contradiction. So therefore, f of y must be equal to y for everything else. Remember, x or y are interchangeable. So we have concluded that in the first case, f of y equals to 0 for all y. So function is 0 function. In the second case, f of y equals to y for all y. So this is the identity function, and those are the only two. So what is left to be said is that this is a very common thing for functional equations. It sounds really silly, but we need to say this, right? Which is that checking both fx equals to 0 and fx equals to x work. Now we need to say this because technically speaking, we don't know that the functions that come out of this work, right? All we are doing is finding out things that must be true. Now things that must be true may not satisfy the equation. It is sort of like any normal equation you solve, right? You may have to reject solutions. So you need to acknowledge that you check and they both work, otherwise you will get a mark deducted even if they really both work. Right? So you have to mention that explicitly which of these work even after all your steps. In this case, you don't really need to explain much because it is very obvious that if fx is 0 or fx equals to x, the statement is true. So you just say checking they work. And we're done. Okay, so this question is a little bit like functional equations 101. It is quite nice because it doesn't use anything too complicated. It uses a whole bunch of substitutions, which is the usual starting point of functional equations. 2, you try to match up things such that one side is the same, the other side changes a little bit. Secondly, it showcases the pointwise trap, which is that if you have fx equal to a few options, it may switch between them until you have gotten it established that fx is always equal to one of them or always equal to a particular one of them. Right? And at the end, we just had a little bit of cleaning out the cases, which is usually also how these problems end. You will reduce it until a few candidates, and then you will just try to deal with each of those candidates one by one. This is more or less how most basic functional equations work. And when I say basic, I mean basic round 2 functional equations. Not the kind you see in round 1 where you just do a cyclic substitution and everything cancels out. Okay, so that's all for this video. Thanks for watching, and I'll see you in the next one.